All right, question number 14. Question number 14 is composition, right? Here's what we got. And so basically, you have to take f of x and plug it into g of x. So let's write this down. G of, whoops, that's a parenthesis. We're going to have a little f of x. That's the same thing as saying g. How much is f of x worth? 3x minus 1. So we've got to find g at 3x minus 1. So that's going to be 4 times 3x minus 1 plus 3. Distribute the 4 in. And we're going to get 12x minus 4 plus 3, which is the same thing as 12x minus 1. So which choice is it? Choice B, piece of cake. Question 15. Question 15. Check this out. The first thing that we have to do when you see stuff written like this is convert it back into an easier form to look at. This is the same thing as saying f of g at 8. F of g at 8. So what do? I mean, the first thing we really should figure out is what, Skolnick? Sure. We're going to try and figure out this. And by figure out this, I mean we're going to try and figure out how much it's worth. How much is g at 8 worth? Well, g at 8 is going to be equal to the square root of 2 times 8. How much is 2 times 8? 16. Square root of 16 is 4. So now this business right here, instead of me saying that, this equation is equivalent to me saying f at 4. How much is f at 4 worth? F at 4 is worth, we're just going to plug it in to this equation right here. 3 times 4 squared, that's 3 times 16, which should be 48. An inverse question. If negative 3 comma 1 is in the function p of x, which of the following points would be in the function p? Now what does this symbol up over here mean? Yeah, it means the inverse. What do you know about the inverse? Yeah. Switch x and y. So what point is on the inverse? Yeah, all we're going to do is switch it. And so it's going to be just 1 comma negative 3. Choice D. 17 is directly related to something I told you yesterday. It's an easy question to remember. All you need to know is a fact. The inverse of that equation can be obtained graphically by what? It's nothing more than a pure fact. Is it a reflection? I told you it was a reflection in a very, very, very famous line. Teddy? Perfect. That's all it is. Anytime you have an equation, an inverse is formed by reflecting in that line. That never changes. It's never any different. If you see that on a test, just pick that one. You're done. 18. All right, let's find the inverse of this equation. Let's find the inverse of this equation. Well, how do you find the inverse of an equation? Right? What's step 1? Very nice, yeah. It's just like with coordinates. We're going to switch x and y. What's step 2? Teddy? We're going to try and isolate y. Okay? What do we do next? Go. Whoops. And I always show, so this is equals y, and then I always write my results in terms of function notation. So the inverse is x plus 2 divided by 3. Choice B. All right, last question. Find the inverse of the given function and use composition to justify the results. So it's really a two-part question. Find the inverse we're going to do in red, and then we're going to use composition to justify the results. We're going to do that in blue. First part, find the inverse. What do you do first? We're going to switch it. First, we're going to put a y there because, it's impossible to find the inverse unless we have a y. And then we switch x and y. We reorganize, and we isolate y. So we got x minus 8 equals negative 3y. Divide by negative 3, divide by negative 3. So that you get x minus 8 divided by negative 3 equals y. And I always put this to indicate that it's the inverse. That's it. That's part 1. Okay. Let's mark this down. All right. The stuff in part blue, composition, to use composition to justify your results. This is really training for your pre-calc class. Okay? There is something that I wrote down yesterday that you will have to remember. And if you remember it, it's worth 1 out of the 4 points awarded for this particular problem. Here's what you have to write down, right? So the inverse, I'm sorry. Okay. Here's what you need to write down. So if k of k inverse of x equals x, and k inverse of k of x equals x, then both k at x and k inverse x are inverses of each other. Whoops. And so you really just need to remember that. I happen to have written that down something like 20 times in high school, and I teach this class. And I wrote it down 4 or 5 more times to remind myself of the exact way it should be written. But if you can just write that down perfectly like that, that's worth 1 point. Now, if you're uncomfortable writing it down, then you will have to remember how to do all of the math perfectly in order to get full credit. Here's what I'm going to do. I'm going to sub the inverse into the original. Shoot. Okay, we're going to take the inverse, we're going to sub it into the original. We're going to do this part first. So, k with the inverse subbed into it, x minus 8 over negative 3. What does that equal? Well, that's negative 3 times x, times x minus 8 over negative 3. Close the parentheses, plus 8. This and this reduce, and you're just left with x minus 8 plus 8, which turns out to be just x. Perfect. The first part's working out real nicely. real nicely. Let's do the second part. Let's take the inverse. Let's take the original, and let's sub it into the inverse. So we've got to sub in negative 3x plus 8. And we're going to sub it into negative 3x plus 8 minus 8 all divided by negative 3. All right. Well, the top, right? The top reduces. This and this are just going to cancel away. And you're left with negative 3x. Whoops. That's a 3. Ah, smartboard. Come on. Stop being so dumb. Come on. These two cancel and reduce. And so you got x in the end. So at the end of the day, our statement above was proven. Let's go big screen. Our statement above, this is the work justifying this reasoning, and thus full credit.